1945, the science fiction writer Arthur C. Clarke first proposed that satellites could be used for broadcasting. Using Kepler's laws of planetary motion and Newtonian mechanics, Clarke's paper gave the exact conditions for putting a satellite into geostationary orbit. It was not long before science fiction would become science fact. On October the 4th, 1957, a Russian satellite, Sputnik 1, was launched into space. About the weight of a man and just half a meter across, it circled the Earth at a speed of nearly 30,000 kilometers per hour, completing each orbit in just 95 minutes. Nothing man-made had ever traveled so far, so fast. Two tiny radio transmitters on board the Sputnik broadcast their signals, which could be picked up on Earth by the military, national broadcasters, and even amateur radio enthusiasts. The space age had begun, and the world had changed forever, but there was no music and no pictures. The first satellite television picture was broadcast by Telstar on July the 11th, 1962, an event which so captured the public's imagination that this record rocketed into the charts around the world. Then came color TV. It was another 20 years before direct-to-home broadcasting began in Europe. On the 11th of December 1988, Ariane space flight number 27 blasted off from the Kourou Space Center in French Guiana, carrying the first Astra satellite. Named, imaginatively, Astra 1A, it was commissioned and operated by SES, the Société Européenne des Satellites, based in Luxembourg. Today, SES have 8 satellites in orbit, 7 at the original orbital position of 19.2 degrees east, and the 8th, Astra 2A, at a second position of 28.2 degrees east. Built by the world's leading electronics and engineering companies such as General Electric, Matra, Marconi Space, and Aerospatiale, each satellite can take up to 3 years to build. Astra 1G and 1H were built by Hughes Space and Communications in El Segundo, California. They're HS-601 spacecraft, specifically designed for high power requirements such as TV transmission. Complex electronic systems and precision engineering combine to create some of the most advanced communications, TV and radio technology the world has ever seen. To protect the satellite and its expensive cargo, called its payload, from cosmic rays and solar wind, it has to be encased in a kind of plastic gold foil. That payload is the systems which actually receive data and TV and retransmit them to Earth, the transponders. On board, the satellite also carries its own fuel to power its thruster rockets for maneuvering in space, and the life of the satellite is mainly determined by how long that fuel will last, currently about 15 years. This is the Astra 1K satellite, due for launch in the year 2000, and currently under construction by Aerospatiale of France. With its 54 transponders, manufactured by another French company, Alcatel, Astra 1K will by far outperform any existing satellites for direct-to-home reception. Everything is checked and double-checked. For once in space, the satellite must operate fault-free throughout the whole of its working life. Each Astra satellite weighs about 3 tons, the same as a fully grown elephant. So in order to launch it, you need a very powerful rocket. SES uses Ariane rockets, launched from the European Space Center in French Guiana, and Russian Proton rockets, launched from the Cosmodrome at Baikonur in Kazakhstan. Here, in an Ariane launch, the satellite is loaded into the rocket's nose cone, which is then transported out to the waiting rocket.
8, 7, 6, 5, 4, 3,
Voilà. Ouverture des 2 bras cryotechniques.
1, top.
Ignition.
Around 500,000 tons of thrust from the rocket's liquid-fueled main engines and solid-fuel boosters lift the 3-ton satellite clear of the Earth's atmosphere. In an Ariane launch, 20 minutes after takeoff, at a height of 200 kilometers above the Earth, the Astra satellite is released into a temporary transfer orbit. It sweeps in a giant ellipse around the Earth, as close as 200 kilometers and as far as 36,000 kilometers. At the apex of this ellipse, the onboard thrusters take over to push the spacecraft into its final orbit. Like a giant bird spreading its wings, the satellite unfolds its huge solar panels. They provide the energy to power the craft's electronic systems. With wings outspread, the latest craft measure over 25 meters, tip to tip.
Ignition. Liftoff.
This is a Proton launch of Astra 1G. The Proton, 60 meters tall, is powerful enough to take a 3-ton satellite all the way to its parking orbit, 36,000 kilometers above the Earth at its highest point, in just 7 hours. Only small corrections will be needed to position a Proton-launched spacecraft exactly at the right orbit. To ensure that you can receive TV transmissions 24 hours a day, the Astra satellite orbits 36,000 kilometers above the Earth. At a lower orbit of, say, 300 kilometers, it would circle the Earth every 1.5 hours, and you'd miss an awful lot of programs. Put a satellite on the Moon, which goes around the Earth every 28 days, and you'd only get 1 or 2 days TV every month. But at 36,000 kilometers, about 1/10 of the way to the Moon, the Astra satellite orbits exactly in time with the Earth's rotation. So you can pick up TV and radio channels on Astra 24 hours a day, 365 days a year. From Moscow in the east to Ireland in the west, from the tip of Scandinavia to the Canaries. The onboard thruster rockets, driven by ground control, are used to keep the satellites in perfect geostationary orbit. You see, satellites don't just stand still in space. Gravitational pull from the Earth and the Moon and the effect of solar winds can shift them. Even mountain ranges like the Himalayas can pull them off course. Back down on Earth at SES's ground control center in Château de Betzdorf in Luxembourg, huge parabolic antennae track each spacecraft. The satellite control center monitors the satellites 24 hours a day, engaging the thruster rockets from time to time to keep them in position. Astra broadcasts television and radio programs to over 70 million homes. And before the signal reaches them, it's traveled over 72,000 kilometers at the speed of light, a distance equivalent to going twice round the world, and all in a fraction of a second. The channels are uplinked to the satellites from Betzdorf and from over 20 other locations all over Europe. And there's complete backup. Should any of the transponders suffer technical problems, programs can immediately be switched to another without any loss in transmission. The ultimate test of this backup came early in 1998, when ground control performed a maneuver with the Astra 1D spacecraft that had never been done at SES before. In order to test transmissions from the new orbital position, Astra 1D was flown from 19.2 to 28.2 degrees east, a distance of about 6,000 kilometers. This maneuver, which took about 3 weeks, added 16 transponders, or the capacity to transmit about 100 TV services to the new orbital position. Back at 19.2 degrees east, the backup capacity of the remaining digital satellites took over all the jobs of Astra 1D. With Astra, the only time you'll see a blank screen is when you switch off. And all you need to get all this is a dish, a receiver, and a TV. So that's what goes on behind the scenes to deliver your favorite channels and ensure perfect reception. The world's top scientists, engineers, and technicians, and 3 years of painstaking preparation. Satellites that can be relied on to perform fault-free throughout their lifetime. Launched by rockets powerful enough to lift an elephant weighing 3 tons into orbit. The system managed and monitored by the ground control station at Betzdorf. All this to carry the hundreds of TV and radio channels and other services that millions of people want to see. Astra takes care of the technology. All you have to do is enjoy it.